Okay, so today I will introduce you the third lab for Physics 101. When you check this on your Canvas page, on the Canvas page on the assignment menu, you can find it, the motion in one dimension, constant acceleration by using tracker. When you click on it, you can also reach this from the main page of Physics 101 class Canvas page. Go down to this last submit report 3. Okay, when you click on it, it will take you to this page where you can just download the report template, and when you click on it, you just get this report template. Okay, so the report template for the motion in one dimension part 2, which is a constant accelerated motion in one dimension. And as you can see, you will use the same video file for that you have used in the previous experiment. Two cards video file, and you can download this video file also again from the report page of on the Canvas. Download the video experiment and click on it. You just download this these two files, the one file. Okay, this is one file. When you get this, the video record of the lab cards moving, one is moving with the constant velocity, the other is moving with a constant acceleration. Let me just open it by using Windows Media Player. So this is the video file. And of course, you are going to open up this recording on the tracker software. Okay. So what you do is just open up the tracker software. And on the tracker software, okay, you get this video file, drag it onto the white region on the tracker. So there you have it. So when you play this motion of two cards on tracker, you get this both of these two cards. One is top, the other is bottom, and they both start the motion at the same time. Okay, but one is going with the constant acceleration and the other is going with the constant velocity. So of course, what you are going to do is when you look at the report template and just first, there is this section of pre-lab questions. What you see only here is that the motion of two cards, car A and car B, one is moving with the constant acceleration, the other is moving with the constant velocity. But you get this position versus time graph for two cards. And there are some questions over here that you should answer. And just first to answer these pre-lab questions, and after you finish it, you just put your answer on the next page. You put your answer here this night. So just read the abstract, and there is this introduction, the position, time-dependent position of both motion. One is moving with the constant acceleration velocity, and the other is constant acceleration. And just you read this part, okay? And these information are important. You next you see the objectives and the equipment, etc. So concentrate on the procedure. As what I've done is that I just opened the tracker software and downloaded the video file and just drag the video file over the tracker, open up in the tracker. So that means you are ready first to get the data for both cards. But before that, you are going to answer these parts. First one is what is the pixel size in millimeters, and this link over here is explaining the video link, how to get this information from your tracker file. And you're going to determine the uncertainty. And just, as I said, go over it and just, this is the one that you have already have done in your previous experiment, previous lab, okay? And next one is, please put the following data tables for both cards, or here, card A and card B. And card B, card A is shown as here with the red data points, and card B is shown as the blue data points. Okay, let me show you how to get this. First thing first is that just let me enlarge the font size over here. Put your coordinate system so that somewhere over here, since the motion is in one dimension only, the coordinate axis, y-axis, just crossing the yellow labels on both cards. You see over here, and just bring the x-axis the y-axis crossing the both yellow cards, okay, or going over them. And the x-axis can be anywhere. It may be over here, here, or here. It's not a big deal. Just make sure that the y-axis just go over the yellow labels that are put on the both cards, okay? And this is the 0th frame. How many frames are there? Just check it. 1, 2, 3, 4, 5, 6. You have totally 15 frames. It says 14, but you have also the 0th frame, and 0th frame is also its second frame. So next is you can just click on the axis just to get rid of, but you know that the axes are over here. And next is you're going to put the calibration stick. The calibration stick, it tells you computer the distance scale. So what you do is just, this is a meter stick over here. We together with the marks of 10 centimeters, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you're just going to mark the left end and the right end. And this is done by just pressing and holding the shift key, and just click over the left end over here, and then bring, come over the right end, and again, just click on the shift key and hold it, and just press the left mouse button. So it says over here some number. You're going to just get rid of erase that number and put 1. That means this is 1 meter. Okay. So this just fixes the length scale. And again, by just clicking over this menu, you can get rid of it. But length scale is already implemented. So next is we are going to mark the top card as card A, which is down over here. Yeah, the yellow card, the red card. And we're going to just label the top card as the card A. But for this, what we do is we create point mass, okay, first. So this is mass A, but just change this card A, and the card A is this one, and we are ready for just getting the position versus time data for card A. Make sure that this is at the 0th frame, the starting frame. And as soon as you create the card A, you just go over this yellow label for card A, for the top card, and press and hold for shift and control keys at the same time, so that you can see this circle pointer, and bring the circle pointer just right at the center of the yellow label, and click over it. When you click over it, the tracker will just open up the auto tracker window, as you see over here. And when you click on the search, what does the auto tracker window is going to mark the position of the yellow label, center of the position of the yellow label at each frame automatically. So let's do it. Okay. So what you see now, the auto tracker is already tracked the position of every frame, position of the yellow label at every frame. Okay. So you just got now the position versus time graph data for the card A on a time basis. At 0, the position is, well, it is 10 to the minus 3, minus 3, you know, basically it's 0. At time t is equal to 0, it's almost basically at the 0 position, 0 meter in minutes. At time t is equal to 0.067, it's a little motion in there. At the time this one, so it's slowly it's getting, it's increasing its velocity, right? But anyway, this data is also shown on the position versus time graph over here. It's a typical position versus time graph for a constant accelerated motion. Okay, as you see. So this is the part that you are going to copy. Just copy this image. Before that, you can just bring you know, this time column to the left, time versus x. So you can just copy the image. Sorry. What we do is just select first. Okay. You can select it. Or what you can do is, you might use also the snipping tool in your computer. The snipping tool will just get this data and copy it and put it into your report somewhere over here. But this was only the position versus x, but in fact the report template is showing over here the position in time, the position in x, the velocity in x, and acceleration. So how do you get this? How do you get this? Let's get rid of this part. Let's get our table over here. All right. So we don't need y, right? Because y, we just uncheck this, and we need the x. We need the velocity in the x direction. Also, we need the acceleration in x. So when you click on this 3 x, vx, and x, you get this t time x, the position in the x direction, vx, the velocity in the x direction, and ax. Okay, and then you can copy this. You can copy this image, and then put over here. Okay, by putting this over here, you just get this table. Okay, so this is the way. Don't use this one because it's already checked. This is just a template, and this because you have to get rid of this table. So this was the figure 2 anyway. Let me go back. And on this figure 2, this is a, x, vx, and x. On figure 3, the same thing that we are going to do for the second card. Okay. For the second card, what you are going to do is, on this time, you go over, create again, choose point mass. The next second mass is going to be created, but just change the name to card B. Okay. But the color, just color, select a different color, maybe this bluish color. This one, okay. So let's change the color. Okay, so again, go back in the first 0 frame in your video, and since you are on card B now, what you are going to do is just track again Okay. Track, sorry, track the bottom part again by pressing and holding both Shift and Control keys, and come over the center of the yellow label and click the left mouse button. There you have. There you have the auto tracker window, and just if you click the search button, the tracker will record the position of this button card's yellow label at every frame, and it will record it. Okay, over here. Again, what you're going to do is just go over the table, just uncheck Y, check VX and AX. Okay, so let's make this range. So as you see, the bottom card almost moving with the same velocity. You see over here, 0.7, 0.7. Every frame, its velocity is the same. And its acceleration is very small. In fact, it's effectively, it might be taken as, okay. So again, what you do is just select this data, and copy it, and then put this data over figure 3, okay, just paste it, and you will conclude the second step in the data. So the next steps are just, you will form this compare with X versus time graph. And how to do it, how to do it is just, if you select the part A, for example, and you go over the X versus T graph plot, and click on the right button on your mouse, select compare it, and choose card B. So there you're going to produce the position versus time graph for both cards. This is for card A, the red dots, and these dots are for card B. Okay. So you can just, again, snapshot this or copy image, and then put this over here somewhere over top of the figure 4. Okay. So let's click over here and paste it as I have done it now. So we're done. Okay. So this is step 3, and for the next steps, for 5 and 6, I just leave it to you because it says what is the best model, explains the motion of card A and B, and justify your answer. And next one is please calculate the constant acceleration for card A and the constant velocity for card B using figure 4. This one. And how are you going to calculate it? Just by using the information for the graph. You can maybe producing best plots, or you can go with analyze and choose and analyze curve fit, etc. The curve fit, you can make a curve fit for example, for card A, it's going to be a parabola fit. So from the parabola fit, you will be able to just figure out the acceleration, which is a constant acceleration. And also you can do this curve fit for the card B, which is a constant velocity motion. So you're going to just choose a linear fit, line fit, okay, for card A, and you're just going to get the information for is constant, and A will be the constant velocity. This constant will be calculated by the track anyway. So there are some ways to calculate things. And for the last question, please calculate the uncertainties for constant acceleration for card A and the constant velocity for card B. And you will do it yourself. So this will complete your last report. I try to explain everything. So that's it. This is going to be your last report 2. Okay. So if you have difficulty, if you're going to have some difficulties on doing this report, you can always contact me. Okay. I'm just recording this. Right. So I will put this also on the YouTube playlist, also on the UBS course content as the video, so you can rewatch this video over and over. What to do on the first one. So that's it. I'm just quitting. Enjoy.